A very good morning to all of you. This is your mathematics class of grade 8, chapter 8, comparing quantities, and this is my lecture number 8. Let us see today's key points, what we will be learning in this lecture. We will first of all learn the application of compound interest. In the previous lectures, we have studied the concept of compound interest. Now in this lecture 8, we will study about the application of compound interest. Then I will be discussing the homework solutions of previous lecture, that is lecture number 7. Let us learn now the application of compound interest. The very first application or where we can use compound interest or the concept of compound interest is growth. We know that certain things grow, or we can say they increase. For example, India's population. We know that India's population is increasing. Height of a plant keeps on increasing continuously. Weight of a child increases. Cost of the goods also increases. So, the application of compound interest, we are studying about the growth application. We see certain things grow or they increase. That is India's population. We have seen the example. India's population, height of a plant also increases when we take good care of that plant. Weight of a child also keeps on increasing, and likewise we have another example, that is cost of goods also increases. So the growth per year is called rate of growth. If we are talking about the growth of certain thing or certain commodity, certain thing you can say, then if we are talking about the growth per year, then that is called rate of growth. By what rate that particular thing or particular item is, particular thing is better, is a better word, by what rate a particular thing is increasing. So that is given by, if you are talking about the growth per year, that then that is rate of growth. If this rate of growth is constant, then V is equal to V naught into 1 plus R over 100 raised to the power n. Then if we are supposed to find out the rate of growth, or then we need to use this formula. V is equal to V naught bracket 1 plus R over 100 raised to the power n, or you can use this formula also. We have used this formula for compound interest. You can write this formula in terms of amount and principal, or you can use V and V naught also. So let us see what is this V, V naught, R and N we know, amount and principal we also know. So let us see where V and V naught, this V naught or P, this V naught or P is the present measure of a quantity. Where the in this formula, if we talk about first one, V naught, or in the second formula, if you talk about P, they both are at the same place and they both represent the present measure of the quantity. Either of the formula you can use. If we want to note down, or if we need to find the rate of growth, and if it is constant, then we need to use either the formula V is equal to V naught bracket 1 plus R over 100 raised to the power n, or amount is equal to principal bracket 1 plus R over 100 raised to the power n, where V naught or P, which are at the same place, so they both of them represent the present measure of a quantity. R%, what does it represent? Rate of growth per year. N is the number of years, and V or A, both are at the same place and they represent the measure of the quantity after n years. So we have seen the very first application of compound interest. Basically we will talk about, this is the main application, that is growth and depreciation. First of all, we are talking about the growth. We know that certain things grow or they increase in size. So for example, we have seen the example of the certain things which keep on increasing, like we have talked about India's population, then height of a plant, weight of a child, and cost of goods. Then we have talked about the rate of growth. If the growth per year is we need to measure, then this growth per year is called rate of growth. And this rate of growth, if it is constant, then it is given by the formula V is equal to V naught bracket 1 plus R over 100 raised to the power N. Or you can write this same formula in terms of amount principal. Rate and N are same in both the formulas, so it will not make any difference for those. So where V naught or P represents the present measure of the quantity, R percent represents the rate of growth per year, N is the number of years, and V or A is the measure of the quantity after N years. Now, as I told you that growth and depreciation is the application of compound interest, firstly we have talked about growth. Now, let us see what is depreciation. The value of a machine or vehicle, etc., decreases with time due to wear and tear. So, what do you mean by depreciation? If the value of a machine or a vehicle decreases with time due to wear and tear, then this is your depreciation. And the decrease of the value per year is called rate of depreciation. We have talked about the rate of growth. What was that? The growth per year is called rate of growth. Now, as it is a case of depreciation, so we are talking about the decrease in value. Firstly, we have understood what is this depreciation. If the value of a machine or a vehicle decreases, depreciation itself tells us that decrease. So, if it is decreases with time due to wear and tear, and if we are talking about the decrease of the value per year, then that is rate of depreciation. If the rate of depreciation is constant, then it will be given by this formula. V is equal to V naught bracket 1 minus R over 100 raised to the power N. Here we have taken this negative sign because we are talking about the depreciation, that is the decrease in the value of a particular machine or a vehicle after so many years. If you are trying to sell that particular machine or vehicle, obviously you will be getting a less amount as compared to the amount for which you have already paid while purchasing that. So here we are talking about the depreciation, so minus sign will be there in the formula, or it can be, you can use this formula, amount is equal to principal bracket 1 minus R over 100 raised to the power N. Here you can write down capital R also in place of small r. Here I have written small r, you can write capital R also. So where V naught or P is the present value of the machine, R percent is the rate of depreciation, N is the number of years, and V or A is the value after N years. And let us talk about the lifespan. This is the another term in this application of compound interest. The number of years a machine can be effectively used is called its lifespan, after which it is being sold or as a waste or scrap. So the number of years a machine can be effectively used is called its lifespan, after which it is sold as waste or scrap. This everything, I think this is the word which everyone I think knows very well, because after using a particular machine for certain years, we always think that now it is the time to sell that particular machine. So the number of years a machine can be effectively used is called its lifespan. Coming to homework part. Your homework is from NCERT book. You are supposed to complete question number 10 and question number 11 of exercise 8.3 in your homework notebook. Dear children, these two questions are totally based on the concept of growth and depreciation, which we have discussed in the previous slide of this lecture number 8. Now, coming to the homework solutions of exercise 8.3 from NCERT book. I gave you the questions from exercise 8.3 NCERT book, that is from question number 4 to question number 9. Let us discuss them now. Question number 4 says, I borrowed rupees 12,000 from Jamshed at 6% per annum simple interest. Principal is given to you as 12,000 rupees. 6% per annum is the rate of interest. The important point here to note is that interest is being calculated in on the basis of simple interest, and time given to you is 2 years. Had I borrowed this money, the principal is same, at extra 6% per annum compound interest, then what extra amount would I have to pay? So actually the person has borrowed, or here the person indicated is I, that is I borrowed rupees 12,000 from Jamshed at 6% per annum simple interest for 2 years. If this money, this amount would have been borrowed at 6% per annum compound interest, what extra amount would I have to pay? This is what you are supposed to find out. Now let us see the solution. Simple interest we are supposed to find out. Simple interest to be paid for 2 years at 6% per annum. So principal here is 12,000 rupees and time is 2 years. Rate of interest is 6% per annum, and we need to find the simple interest first, so that then only we will be able to compare. We will find simple interest as well as compound interest. Then we will come to know what extra amount would I have to pay. So simple interest case we are taking first. Principal is 12,000 rupees. Time is 2 years. Rate of interest is 6% per annum. Now we know the formula for SI, that is simple interest, P into R into T divided by 100. So this is your principal, this is your rate, that is 6% per annum, and time is 2 years. So putting the values in the formula, you will be getting 1440. This is your simple interest for 2 years. Now compound interest is to be paid for 2 years on the same principal. So principal is 12,000. Rate is 6% per annum, time is 2 years, but here we are supposed to calculate the compound interest. So we know the formula of compound interest. This is amount is equal to principal into 1 plus R over 100 raised to the power n. This is the formula we know. So after solving the bracket, you will be getting 100 plus 6 over 100 raised to the power 2. Then 100 over 100, 106 over 100 into 106 over 100 will be written 2 times, because the power or the time is given to you as 2 years. So after multiplication of 106 into 106, you will be getting 11,236. This will be your you will be getting after multiplication of 106 and 106, that is 106 square will be 11,236. Then after solving, you will be getting the amount as 13,483.20. This is your amount, but we need to calculate the compound interest. So compound interest is given by the formula amount minus principal. Putting the value of amount and principal, this is your amount 13,483.20. This is your principal. So after solving, you will be getting 1,483.20. This is your compound interest. Now we need to find out what extra do I need to pay. So simple interest we have calculated, compound interest we have calculated. We need to take their difference. So taking their difference, it will be 1,483, this is your compound interest. 1,440, this is your simple interest. So it will be 43.20. So 43 rupees decimal 20 will be the extra amount to be paid as compared to when we will be comparing compound interest and simple interest. Now coming to question number 5. Vasudevan invested rupees 60,000 at an interest rate of 12% per annum compounded half yearly. This is the case of compounded when the interest is being compounded half yearly. What amount would he get after 6 months and after 1 year? There are 2 parts in this question, but the point here to note is that we need to find the compound interest when the interest is being compounded half yearly. So let us see first part. Here in this case, the principal is rupees 60,000, rate is 12% per annum, time given to you, we are taking first part, so time is 6 months. And we know, children, that if it is a case of half yearly, then rate is to be divided by 2. We have done this. 12 by 2, that will give you 6%. Time here it is given to you in months. First of all, we have converted into years, and then it should be multiplied by 2. It will be 1 year after solving. So rate is to be divided by 2. Time is to be multiplied by 2. So rate here will be 6%. And time will be 1 year. Putting the values in the formula, amount is equal to principal into 1 plus r over 100 raised to the power n. Principal is 60,000 rupees. Amount, principal is 60,000. Bracket 1 plus r rate of interest is 6%, because it was being compounded half yearly, and time we have calculated as 1 year. So solving the bracket, it will be 60,000 into 100 plus 6 over 100 after taking the LCM raised to the power 1. So it will be 60,000 into 106 over 100. That will give you 63,600. This is your amount. Let us see now second part. Here in this case, principal is 60,000 rupees. Rate is 12% per annum. Time here is 1 year. So rate, as it is interest is being compounded half yearly, so the rate is to be divided by 2. We have divided by 2, that will be 6%. Time is to be multiplied by 2, so we have done it. 2 years, time will be now 2 years. Putting the values in the formula, you will be getting 60,000 into 1 plus r over 100. R is 6% raised to the power 2. Time here is 2. So solving it, so it will be 60,000 into 100 plus 6 over 100 after taking the LCM inside the bracket. It will raise to the power 2. So 60,000 into 106 over 100 into 106 over 100, because the time was 2 years, so it will be written twice. So after multiplying 106 or taking the square of 106, you will be getting 11,236 over 100 into 100. It will be. So after solving, you will be getting the amount as 67,416. So coming to question number 6, it is Arif took a loan of rupees 80,000 from a bank. If the rate of interest is 10% per annum, find the difference in amounts he would be paying after 1.5 years if the interest is compounded annually. This is the first part. Here in this question, principal is given to you as 80,000. Rate of interest is 10% per annum. We need to find the difference in amounts he would be paying after 1.5 years if the interest is being compounded annually and interest is being compounded half yearly. So in these two parts, again, first part we need to find the interest amount when the interest is being compounded annually, and in the second part also interest is being amount is being calculated, but the interest is being compounded half yearly. So let us see first part. Principal is 80,000. N is given to you as 1.5 years. Rate of interest is 10% per annum, as it is the case of compound interest being compounded annually, and I told you that if time is given to you like this, that 1.5 years, 2.5 years, then first of all you need to calculate the amount for 1 year, and then that particular amount will be the principal for next half year, and then you are supposed to add those two interest which you will be calculating using a simple interest formula, and the amount. Likewise, I will be showing you. So we are using the formula. Amount is equal to principal into 1 plus r over 100 raised to the power n. This formula we know. Putting the values, as I told you, we are taking here n is equal to 1. Rate of interest is 10%, so 10 over 100. So, and the principal is 80,000. So after solving the bracket, it will be 100 plus 10 over 100 raised to the power 1 into 80,000. So 80,000 into 110 over 100, it will give you 88,000. Now this amount will be the principal for next half year. Let us see. So principal of half year will be 88,000. simple interest formula we are using now. 88,000 into P into R is 10% into 1 by 2. 1 by 2 is the time into 100. P into R into T over 100. So 440 into 10 into 1, it will be, you will be getting 4,400. So amount after 1.5 years will be, we are adding the previous amount. For 1 year we have calculated using compound interest formula, and this interest or this amount basically, because we have used the amount of the previous year as the principal for the next year, so it will be 92,400 in total. Now coming to second part, principal here is 80,000, rate of interest is 10% per annum, time here is 1.5 years, but the interest is being compounded half yearly, and for half yearly we know that we need to divide rate by 2, that will be 5%. Time is to be multiplied by 2. So we have solved it. First of all, it will be 3 by 2 years. Then it will be multiplied by 2. It will be 3 half years. So putting the values of principal, rate and time in the compound interest formula. This is the formula. Amount is equal to principal into 1 plus R over 100 raised to the power. So putting the values, 80,000 into 1 plus 5 over 100 raised to the power 3. So after, when we will be solving the bracket, 100 plus 5 over 100 raised to the power 3 it will be. So 80,000 into 105 over 100 into 105 over 100 into 105 over 100 3 times, because time is 3 years. So it will be, after solving you will be getting 92,610. Difference between the amounts we need to calculate. This was the amount when the interest is being compounded half yearly. This was the amount when the interest is being compounded annually. So 210 rupees is the difference between the two amounts in two different cases, when the interest is being compounded annually and when the interest is being compounded half yearly. So here comes question number 7. It says, Maria invested rupees 8,000 in a business. She would be paid interest at 5% per annum compounded annually, and you need to find the amount credited against her name at the end of the second year and the interest for the third year. Now coming to the solution part. Here the principal is 8,000 rupees. Rate is 5% per annum. N is equal to 2 years. We need to find the amount first in the first part. So amount formula we know that amount is equal to principal bracket 1 plus R over 100 raised to the power N. Putting the values, it will be 8,000 bracket 1 plus 5 over 100 raised to the power 2. Then it will be 8,000 into 100 plus 5 over 100 raised to the power 2. We have solved the bracket here in this step. Then 105 over 100 will be written twice, because n was 2 years, n is 2 years in this case, and it will be further multiplied to 80,000. So it will be, you can cancel out 105 over 100. It will be 21 over 20 into 21 over 20 into 80,000. So after solving you will be getting 8,820 as your amount. So the amount credited at the end of the second year is 8,820. This is what we are supposed to find out. Now second part was, we need to find the interest at the end of third year. So let us see now second part of the same question. As we know, dear children, that in the case of compound interest, the amount of the previous year will be the principal for the next year. This is what we have done here in this question also. So we are supposed to find the interest for the third year. So what we have done, we have taken the amount of the previous year as the principal for the third year. So that is 8,820. So using compound interest formula, we will be putting the values in the formula. That will be P into R into T. T here we are taking 1 year because we need to find the interest for third year only. So we have taken N as 1 year. So after solving, you will be getting, it will be 441. This will be the answer. After solving, you will be getting 441. So the amount credited at the end of the second year, so let us see what will be the amount. It will be 8,820. This was our first part, and the interest for the third year is 441. This is your answer. So I hope all these, both the parts are clear to you. In the first part, we have used compound interest formula, and in this part, as we are supposed to find the interest for the third year, so what we have done, we have taken the amount of the previous year, that is second year, as the principal for this year, and then calculated the interest. Simple as this. So coming to question number 8, find the amount and compound interest on 10,000 rupees for 1.5 years at 10% per annum compounded half yearly. These types of questions we have already done. So let us see how we will be doing in this question again. Would this interest be more than the interest he would get if it was compounded annually? So dear children, in this question also we need to find the amount and compound interest when the interest is being compounded half yearly and when it is being compounded annually, and then we need to compare the two. So let us take first case. Principal is 10,000, rate is 10% per annum, time is 1.5 years. Since the interest is compounded half yearly, we are taking first the case of half yearly. Then as we know that we need to divide the rate by 2. So 10% was the rate of interest. So it should be divided by 2. So you will be getting 5% as the rate of interest now. N is given to you as 1.5 years. So it will be 3 by 2 into 2. So total it will be 3 half years. So rate of interest will be 5%. Time will be 3 half years, and principal is rupees 10,000. So putting the values here in the formula, it will be amount is equal to principal into 1 plus r over 100 raised to the power n. So putting the values, 10,000 bracket 1 plus 5 over 100 raised to the power n, that is 3. So after solving the bracket, in the bracket you will be getting 100 plus 5 over 100 raised to the power 3. Then this factor will be written 3 times because the power is 3. And you will be getting, after solving 105 over 100, after cancelling out, you will be getting 10,000 into 21 over 20. 3 times you will be writing it into 21 over 20 into 21 over 20. So after solving, you will be getting 11,576 decimal 25 or 0.25. So this is the amount in the first case we have calculated. We need to find the compound interest also. So it will be the formula, we know that amount minus principal will give you the compound interest. So this is the amount we have calculated. This is 11,576 decimal 25 minus 10,000. We are supposed to subtract these two. Then you will be getting 1,576.25. This will be your compound interest. Now if the interest is compounded annually, how we will proceed when the interest is compounded annually? Principal is 10,000, time is 1.5 years, rate is 10%. So we know the formula. We need to, first of all, as the time is 1.5 years, we need to find the amount for 1 year, and then using the simple interest formula, we need to take the amount of this 1 year as the principal for the half years. This is the case we are doing. We are doing this method when the time is given to you as 1.5 years, 2.5 years, and when it is compounded annually. So putting the values, it will be 10,000 into 1 plus 10 over 100 raised to the power 1. So it will be simple as this. You can solve the bracket, and then it will be 10,000 into 110 over 100. So the amount will be 11,000 rupees. Now this amount will be the principal for the next half year. So the principal for half year, it will be 11,000. So using simple interest formula, putting the values in the formula, P into R is 10% into T. T here is 1 over 2 into 100. So you will be getting 1100 over 2 is equal to 550. So the amount after 1.5 years, we need to add these two, 11,000 plus rupees 550. It will give you 11,550 as the amount. We need to calculate the interest. So compound interest. So it will be amount minus principal. 11,550 minus 10,000. You will be getting 1,550 as the compound interest in this question, in this second part, when the interest is being compounded annually. Now the difference between the two interests we need to find. When the interest is being compounded half yearly, it is 1576.25, and when the interest is being compounded annually, this was the interest 1550. Subtracting these two, you will be getting 26.25. This will be the difference between the two interests, as it was the requirement of this question. So the interest will be 26.25 more when compounded half yearly than the interest when compounded annually. This was the question. So coming to question number 9, we need to find the amount when Ram will get on rupees 4096 if he gave it for 18 months at 12%, 12.1/2% per annum, interest being compounded half yearly. Again, this is the question of half yearly. So let us see. Principal is given to us as 4096. Rate is 12.1/2% per annum. Time is 18 months. Since the interest is being compounded half yearly, we need to divide the rate by 2. So first of all, we have written it will be 25 over 2 into 1 over 2. That will give you 25 over 4%. And the time is 18 months. First of all, we have converted into years. 18 over 12. We need to divide into 2 by 2 because the time we need to find the interest when it is compounded half yearly. So it will be 3 by 2 into 2. That will be 3 half years. So this is the formula we know. Putting the values in this formula. Principal is 4096. Rate is 25 over 4 after being divided by 2. And time is 3 half years. It will be 1 plus 25 over 400 raised to the power 3. So you will be solving the bracket. You will be getting 400 plus 25 over 400 raised to the power 3. And then 4096 into 425 over 100 will be written thrice, 3 times, because the power is 3. The time is 3 years, 3 half years. So after cancelling out, you will be writing, you can write them as 17 over 16, or you can directly multiply also. So you will be getting the amount as 4913. So the required amount is 4913. Thank you so much, dear children.